This is name of the unit, that is thermal analysis. Okay. Now already I have told you in structural analysis we have potential energy and we have principle of minimum potential energy that we have used for deriving the finite element equation. But in case of thermal analysis, we don't have this type of concept. Okay, that is principle of potential energy. Like that, we don't have any concept in thermal analysis. So we are using other approach. That approach is this one. It is weighted residual method. Weighted residual method. Okay. Now here we start with this method. That means here while before going to derive the finite element equation, we should know the method which we are using for that. Okay. Here we are using method of weighted residual. Okay, or weighted residual method we are using. So I will start with the steps of this weighted residual method. Okay. Now in weighted residual method there are a lot of methods. That is point collocation, least square method, Galerkin method. Okay. Out of these methods, we are using the Galerkin method for formulation of the finite element equation of the thermal problem. Okay. See here, this method is very useful method for solving the differential equations or for formulating the finite element equations. And one more thing, here it is applicable in all disciplines. So it is very important to understand this method. Okay. And for future also, this method is very important. Repeating this. Now, in Gallerican method, there are two approaches. One is classical approach, and one is approach which we are using for formulation of finite element analysis. Now, initially, I will start with the classical approach. Okay, I will show you how to solve the differential equations by using this classical Gallerican method. Okay, that means I will take some applications and that I will show you how to solve that applications by using classical Gallerican method. Then I will go for the formulation of the finite element equation. Okay, means how Gallerican method is used to formulate the finite element method or finite element equation. That means system of linear equations. That means how we can convert differential equations to the system of linear equations. Okay, by using the Gallerican method that I will show you. Then we will use that method for thermal analysis. One more thing I want to tell you here. Here you see, this is a new concept for you, and here this concept is somewhat complicated as compared to other concepts. So be uh, serious about this. Okay, and try to understand. If you have doubt, you can ask me at any time. You can stop at any time. And I have given a lot of lectures on this thermal analysis in the college, outside the college also. Okay, and here in number of colleges there these methods I have taught. Okay, so you take the benefit of this and you try to understand. Now we will start the weighted residual method. Now already I have told you here this first sentence, conversion of differential equations into system of linear equations. That is the purpose of finite element method. And this system of linear equations is solved by any of the suitable method. It may be Gauss elimination method, it may be Gauss Seidel method, it may be iterative method, or it may be direct method. Okay. Now this is important thing. What we are doing, we are converting differential equations into system of linear equations by using APM. By using APM. Already I have told you your differential equation for thermal analysis, one dimensional thermal analysis, it is d2t by dx square, it is equal to 0. For structural analysis, it is due to u by dx square, it is equal to 0. For fluid analysis, due to phi by dx square, it is equal to 0. These are the differential equations for different disciplines. That is, I have taken 3 disciplines and it is applicable for electromagnetic as well as other disciplines also. That means what I want to say, tell you here These all differential equations, if you observe all these differential equations, these all differential equations are of same nature. Only variable will be different. Only variable is different. In thermal analysis, it is temperature. In structural analysis, it is displacement. In thermal analysis, it is potential function phi. Okay. Now, if you observe these differential equations, these equations are same. Okay. You can devise any method for one discipline, and that can be applicable for other disciplines. That means we can write one algorithm, okay, and that algorithm we can use for other disciplines also. One more thing, any engineering problem, not only structural, or all engineering problems are written in the form of differential equations. Okay, so solving the differential equation is very important thing. Okay, and here in some disciplines we have some concepts like principle of minimum potential energy. Okay, by using that concept we can formulate the finite element equation, but in maximum disciplines we don't have concepts like principle of minimum potential energy. So in these disciplines we have to go for this weighted residual method. Weighted residual. Now, how this weighted residual method is working and what are the steps of this weighted residual method? Initially you have some problem for understanding, but when we proceed, when we start the numericals, it will be simple, and it is simple when we start the numericals. Okay, now weighted residual method. Now what is weighted residual method? In weighted residual method, here this method can be used for obtain the solution of linear nonlinear equations. That means any type of differential equation can be solved by this method. It may be a linear differential equation, it may be a nonlinear differential equation, and under linear nonlinear it may be ordinary differential equation or it may be partial differential equation. Okay, all these type of differential equations can be solved by this weighted residual method. Okay, now how it is going to solve, how this method is going to solve the differential equations. Now see here characteristic matrix can be obtained directly from the governing differential equation. uh, that we will, I will show you, I will prove it how characteristic matrix. Characteristic matrix means it is a property matrix, or in structural analysis it is a stiffness matrix. Okay, it is stiffness matrix in structural analysis. It is known as a characteristic matrix. Can be obtained directly from the governing differential equation. There is no need of the concepts which we have taken, that is principle of minimum potential energy in case of structural problems. Okay, that is characteristic matrix can be obtained directly from the governing differential equation. That you can skip this sentence, that you will get when we use that weighted residual method or Galerkin method for finite element formulation. Okay, next one, this method starts from the approximate solution. Approximate solution. Okay, that means initially we have to approximate the solution. Initially we have to approximate the solution. That means initially we have to assume the solution. We have to assume the solution. Okay, do you agree with this? If you have differential equation and if you want to solve the differential equation, here by analytical method we are taking direct integration. Do you agree with this? But in weighted residual method, what we are doing, we are assuming the solution. We are assuming the solution. Now, when we put that assumed solution in the differential equation, that will not be giving correct result. Okay, that will not be giving correct results. It will give some error. It will give some error. That error is known as residual. Okay, that means by using approximate solution. Approximate solution means by using assumed solution. Assumed solution, governing equation is solved. Governing equation is solved, which gives the error. That error is known as a residual. That error, you have to remember this name. This error is residual. Okay. Now, next one. Now our task is to minimize the residual. Our task is to reduce the residual to 0. For making the residual 0, here we have to multiply residual by weighting functions. weighting functions. What are the weighting functions? How to select the weighting functions? That also I will tell you. Okay. But here you have to remember the steps only. Okay. Weighting functions. Now weighting functions are the functions of the coordinates only, and that residuals are multiplied by the weighting functions. Okay. And the product is integrated. Product is calculated at number of locations, and integration of that product is equated with the zero. That will give the solution to the differential equation. Okay. Here you have to read these lines. Okay. Here you will not get idea of the weighted residual method. I will explain with differential equations. Just here you have to remember the steps. Remember the steps. Ajay Madurkar. You have to remember. Just you have to remember the steps. Okay. Just you have to remember the steps. First step is you have to assume the solution. It is known as trial solution, or it is known as assumed solution. Okay. Then you put this trial solution in the governing equation. Governing equation is in the form of differential equation. Governing equation is differential equation, which you want to solve. You put this trial solution in the governing differential equation. Okay. Now, this is your assumed solution. This is your assumed solution. This is not correct solution. Where is this? This is approximate solution. When we put this in the differential equation, it will not be solved. It will not be solved. It will give some error. It will give some error. That error is known as residual. That error is known as residual. Okay. Where is this? Now our aim is to make this residual zero. For making this residual zero, we have to multiply that residual by weighting function. By weighting function. Okay. Now, and the product is calculated at number of locations, and integration is taken over the domain of the problem. Okay. That is, suppose if I use R as a residual and weighting function as a W, and if I take the integration over the domain, and if I equate with zero, this will result in the solution of the problem. Now this I will prove you. This is, you have to remember, this is just the steps of the problem. Okay. Next I will ask the steps. You have to remember this. What we have to do. Okay. Have you got it? Any doubt here? Roshikesh Dore,
Yes, sir.
you just remember the steps.
Okay, sir.
Don't go for understanding of the steps. Okay. You will understand these steps when we start the problems, or when I start explanation with the differential equations. Okay. Now you write down the steps on your notebook, or you can take the photo in your mobile also. You can capture this screen if you are watching the lecture on mobile. Okay. Over. Rishikesh Kumbar, is it over?
Yes, sir.
Preeti Digare. Preeti Digare, is it over?
Yes, sir.
Okay. Have you note down? Have you note down these tips? Okay. Now here you have noted the steps. Now we will apply these steps to the problem. Now consider the differential equation, governing differential equation. Here d phi minus f. It is a short form of the differential equation. It is a short form of the differential equation. It is like this. You see here. It is suppose it is a second degree equation, that is d2 phi by dx square. Okay, plus a or b into d phi by, sorry, into d phi. Just a minute, I will clean it. Next is this is d2 phi by dx square d phi by dx into a, it may be constant, there may be some constant, there may not be constant. Next phi minus f, this is equal to 0. Okay, so here for all these derivatives, and this constant, we have taken this as a d. Okay, are you getting this? So here this is the short form for writing the differential equation. This d may be any number of terms. It can represent the linear equation, it can represent the non-linear equation, it can represent the uh, ordinary differential equation, it can represent the partial differential equation, or it can represent the first order differential equation, it can represent the higher order differential equation also. Okay, here I have taken simple example, it is a higher order differential equation. Okay, higher order differential equation, it may be of any order. Have you got it? You see this one, it is the form of differential equation. Abhishek Sutar, you see this I will explain again. Here I have taken the, this is a short form of the differential equation. Okay, d phi
Yes, sir.
minus f is equal to 0. d d it it may be any order of differential equation, that is d2 phi by dx square. There may be constant also, or there may be variable also. If it is a non-linear, there will be variable. Okay, suppose it is a plus p d phi by dx plus phi minus constant. In place of f I can take constant also. Okay, suppose c equal to 0, plus or minus, it may depend upon the actual differential equation. Okay, means this is the differential equation. Now you tell me what is the first step in Gaussian method? What is first step in Gaussian method? Rishikesh Kumbar. Sorry, what is the first step in weighted residual method? Not Gaussian method. Weighted residual method.
Approximate solution.
You have to approximate the solution. Now what is the solution here for this problem? Can anyone tell what is the solution for this, or for this? What is the solution for this differential equation? If I write here your general equation, you are writing the general equation. Suppose dy by dx plus constant equal to, or plus 2 is equal to 0. What is the solution for this differential equation? It is y as a function of x. Am I right? लक्षात दे का रे सोल्यूशन काय असते डिफरन्शियल इक्वेशनला? ऋषिकेश कुंभार, what is solution of this differential equation? Is it correct? Shreyas Chawle, are you present here? Shreyas?
Yes, sir. Present, sir.
Okay. Solution to the any differential equation, that is the variable as a function of, it's a independent variable. Am I right? Alright, now क्या differential equation चं solution काय असणार आहे? It will be like this. Am I right? Do you agree with this? You please, anyone has to give me a response.
Yes, sir.
Okay. Now next one. Now our aim is to apply. Approximate the solution. Now next one, assume trial solution. Now how we are assuming the trial solution? Trial solution is in the form of polynomial. Now here your dependent variable is phi. Therefore trial solution for the phi is like this. suppose this is a trial solution. I have taken 5 bar because it is a not correct solution. It is a trial or it is a approximate solution. Approximate solution 5 bar is equal to Ci Fi x, summation of Ci Fi x. Now, what is meaning of this Ci Fi x? It is a one polynomial. I have written here in short form. Now, it is in the form of like this. It is C1. If you start from C1 plus C2 x plus C3 x square plus so on. Do you agree with this? Here, this is in the form of polynomial. I have selected the approximate solution to this differential equation. Are you getting this? Okay. Here, trial solution. This is a second step. How to assume these solutions? What is the criteria for this approximation? Okay. That we will discuss later. But you have to remember this is a trial solution. It is in the form of polynomial. Okay. Agree with this. Here Ci is I is 1 to n. That means C1, C2, C3. Okay. That is next is Fi x means it is x raised to 0, x raised to 1, x square, x cube like that. Okay. Or it may be of any nature, but it should be the function of x. Okay. Or it should be function of coordinate. Do you agree with this? Have you got this form? It is a short form of the polynomial. This one. That is 5 bar is equal to summation of I is equal to 1 to n Ci Fi x. Okay. And when we expand this polynomial, it will be taking this form. Do you agree with this? Now this is the approximate solution to this differential equation. This is the approximate solution to this differential equation. Do you agree with this? Or this is the assumed solution to the governing differential equation. Okay. Any doubt here? Here, this concept is new for you. Okay. But in higher engineering, you have to understand this type of concepts. Okay. Now this is the approximate solution. Now what is next step after assuming trial solution? What is next step? Yes, can anyone tell? Pranjal Shelar, what is next step? I have assumed the solution. Now what is next step? Pranjal Shelar. Akshay Patil. I want to solve this differential equation. For that purpose, I have assumed this solution. Now, what is next step in weighted residual method? Yes, have you taken note of that steps? What is the next step, Rishikesh Dore? Saurabh Pawar.
Yes,
Here,
sir.
yes, these steps should be on tip of your tongue. Okay, what is next step? Saurabh, can you tell me?
Making residual 0.
No, before that we have to solve the differential equation. Now we have to calculate the residual. How we can calculate the residual?
Governing equation.
You have to use this approximate solution in the governing differential equation. That means you have to solve the differential equation by assumed solution. If this solution is not correct solution, this is not correct solution. It is an assumed solution. When we put this in the differential equation, it will result in some error. Am I right? Do you agree with this? This will result in some error. That means if I use this solution in this differential equation, it will result some error. Why? Because it is not correct solution. Do you agree with this? Means if I write here d phi bar d phi bar is my approximate solution, minus f. Can I get 0? Can I get 0 on right side? Shreyas Choule, can I get 0 on right side? Shreyas?
Yes, sir.
Yes? Yes or no?
Sir,
Yes, if you have doubt, you can ask me. I will repeat again if you have doubt.
yes, sir. 0 येईल सर.
0 येईल.
हा सर, म्हणजे पहिल्या इक्वेशन मध्ये आपण डी फाय मायनस एफ इज इक्वल टू 0 घेतले ना.
बरोबर आहे. d5 मायनस f इज इक्वल टू 0 आहे. बरोबर आहे. ठीक आहे. आता हा फाय आहे तो सोल्युशन नाही याचा. इट इज नॉट सोल्युशन ऑफ दिस.
अप्रॉक्सिमेट सोल्युशन आहे म्हटल्यावर 0 येणार नाही ते.
येणार नाही ना. It is not equal to 0. It is not equal to 0. Do you agree with this? Okay. And this is known as a residual. Okay. Do you agree with this? See here, when we put this assumed solution in this governing differential equation, you will get some error. Error means on right side you will not get the 0. That error is known as a residual. That error is known as residual. Means here I am putting phi bar in the differential equation. Means I am solving the differential equation by trial solution, by assumed solution. Okay. When I solve that differential equation by trial solution or assumed solution or approximate solution, I will get some error. Okay. That error is known as residual. Here, this you will not get equal to 0. You will not get equal to 0. And that term which we are getting, that is known as a residual. Actual, if it is a correct solution, if phi bar is correct solution, then there should be 0 on right side. Okay. But you will not get 0 because it is a approximate solution. Okay. There will be some term on right side, and that term is an error in the solution. Okay. And that error is known as a residual. Have you got this concept? Saurabh Pawar, have you got this? Saurabh Pawar.
Yes, sir.
Rishikesh Kumbar.
Yes, sir.
Yes, sir.
Akshay Shinde. Akshay Shinde.
Yes, sir. Yes, sir.
Have you got this?
Yes, sir.
Now you tell me next step. You tell me next step. Here I will clean this. Here put trial solution in governing differential equation is over. Now when we put this trial solution in governing differential equation, you will get some error. That error is not equal to 0. Okay. Here I have used the trial solution. This trial solution in this governing differential equation, that will result in this residual. Okay. Over. Now what is next step? Akshay Patil. Akshay Patil, he is not attending the lecture, I think. Pranjal Shelar, what is next step?
Making residual 0.
Making residual 0. For making residual 0, what we have to do? Multiply residual by weighting functions and integrate the product over the domain. Okay. That means you have to select the weighting function. You have to select the weighting function. Okay. Weighting function. Now weighting function, for making the residual 0, we have to select the weighting function. Weighting function is function of weighting function. I will use notation wi for weighting function. It is function of coordinates. It is function of coordinates. Okay. Bear with this. You have to remember this. This is a function of coordinates. And what is exact type of weighting function? That depends upon the method under the weighted residual method. Okay. That means there are different subtypes of the weighted residual methods. Okay. Depending upon these types, okay, we are going to select the weighting function. Now, how to select that I will explain later. Before that, you have to remember, you have to select the weighting function, and you multiply, you take the product of weighting function and residual. Means you take the product of residual and weighting function, RWI, and you have to integrate this product. This is a residual R. This is weighting function. Okay, you integrate this product over the domain of the problem and equate with the 0. That will give the solution to the problem. Now, have you got these steps? श्रेयस काही शंका असेल तर विचारू शकता बरं का, कारण हा concept it is new for you. If you here I have written RWI equal to 0. Okay, RWI over dV I have to equate with 0. Says शंका असेल तर विचारू शकता. Saira Shinde, if you are doubt, you can ask me. If you ask to repeat from the start, then also I am okay. Okay. Now here R is we have calculated this one, that is by putting the trial solution in differential equation. Then you will get, this is d phi bar minus f. This is your R. You can see here, this is R, and R is we have calculated here. And weighting function, till we have not got the weighting function. Okay, do I agree with this? Now this equate with 0, that will give the exact solution. Okay, you have to remember these steps again. Here this I have written in general differential equation. This is, I will explain once again. This is your general differential equation. It is in the form of, here it may be partial differential equation, delta phi by delta x, or delta 2 phi by delta x square plus delta 2 phi by delta y square. If it is a partial differential equation, then this variable is also partial, x and y. Okay, do you agree with this? Are you getting this? Now I will take, for simplicity, I will take only one variable, that is an ordinary differential equation. Okay, suppose this is a one ordinary differential equation. This one. Now we want to solve this differential equation. Our aim is to solve this differential equation. For solving this differential equation, how weighted residual method is used? In weighted residual method, we have to approximate the solution. That means we have to assume the trial solution. We have to assume the solution. Okay, we have to assume the solution. This one. Now this assumed solution is in the form of polynomial. That is phi bar is assumed solution. It is Ci fi x. It is in the form of C1 plus C2x plus C3 x square. It is a short form of this polynomial. Okay. Now after that, you put this trial solution in the governing differential equation, and solve the differential equation by using trial solution. Okay, when we solve the differential equation by using trial solution, we will get the residual. That is a error. Okay, and that error is not equal to 0. Why? Because our solution is not correct solution. Our solution is approximate solution. Now our aim is to make this residual 0. For making the residual 0, we have to select the weighting function. Now weighting functions we have selected, and product of residual and weighting functions is taken over the domain, and it is equated with the 0. Okay, when we equate this product with 0, we will get the value of phi. And that is your correct solution. Okay, here I have told you only steps. I will prove it how it is correct. Okay. Now before going to that, we have to work on the weighting functions. Weighting functions. Okay. Now here you can calculate this residual just by putting this approximate solution in the differential equation. But how to select the weighting function? How to select the weighting function? That concept I will tell you. Now, here depending upon the selection of weighting function, we have different methods. Out of that, I will say it is not mathematical lecture. It is a lecture of mathematics. It is a lecture of finite element method. Now, method which is suitable for finite element analysis, that I will take here. Okay. Now that method is not as known as Gullikin method. Known as Gullikin method. Okay. Now, Gullikin method is generally used in the formulation of finite element equation or in the formulation of FEA equation. Okay. Where with this? Or for finite element analysis of the different domains or different disciplines, this Gullikin method is used. Why it is used? That also you will get. Okay. Now, here in this method, it is same to the weighted residual method, or it is one type of weighted residual method. We can see it is one type of weighted residual method. Only thing is it has one criteria for the selection of weighting function. What is that criteria for selection of weighting function? If you get that criteria for selection of weighting function, you can understand this Gullikin method, or you can tell why this method is applicable for finite element formulation. Okay. Now here it is weighted residual method in which multiplier is a multiplier. You have to remember this. This is important thing. Important thing. Weighted residual method in which multiplier of the trial solution is used as a weighting function. You have to remember this. Multiplier of the trial solution, okay, is used as a weighting function. Now, what is a multiplier? I will tell you. Now, here I have written here phi or phi bar. That is trial solution or approximate solution. It is summation of I is equal to 1 to n. Okay, ci fi x, ci fi x. Now multiplier of the trial solution. Multiplier of the trial solution. Now here multiplier of this trial solution, which is the function of coordinates, is fi x. Fi x, that is fi x is selected as a weighting function. That is this function, weighting function. Okay, wi. I have got it. It is a weighted residual method in which multiplier of the trial solution is taken as a weighting function for solving the differential equation. Okay. Now next one, here again I will show you by considering the governing differential equation. Here consider governing differential equation, same type of governing differential equation. First step in Gullikin method is approximate the solution. It is same to the weighted residual method. This method is weighted residual method. Therefore, first step in Gullikin method and weighted residual method is same. Okay. Now here we will assume the trial solution as a phi bar summation of ci fi x. Okay. Do you agree with this? Now next one, put the trial solution in governing differential equation. Same thing. That is, you put this in the differential equation. I solve this equation to calculate the residual. This is a residual which we have calculated, and it is same step to that of the weighted residual method. Okay. After that, we have to select the weighting function. We have to select the weighting function. I have not written here. Weighting function wi. That weighting function is fi. Okay. Do you agree with this? Now next one. Here multiply a residual by weighting function and integrate the product over the domain equate with the 0. Now here I have written this is the equation formed by integrating the residual and weighting function. Now weighting function is I have written in Gullikin method, weighting function is multiplier of the unknown parameters. Okay, wi is equal to fix. Okay, wi is equal to fix. Now we will turn towards the finite element method. Finite element method. Now in finite element method, what we are doing? We are writing the field variable. Suppose it may be temperature, it may be displacement, as a product of shape function matrix. Okay, shape function matrix into nodal displacement matrix. Sorry, into nodal temperature or nodal displacement matrix, depending upon the discipline. Okay, here it is T. This is your U. Okay, now if you observe these equations, here, these are the unknown parameters or unknown constants. Okay, here this is Ni Ti plus Nj Tj. Here Ni and Nj are the functions of x. Am I right? Here also we are writing Ni Ui plus Nj Uj. Here Ni Nj, these are functions of Ni. Ni is function of x. Okay, Nj is also function of x. Okay, where is this? Now see here this is your trial solution. This is your approximate polynomial, assumed polynomial. Okay, that is the second step in finite element method. We are assuming the polynomial, interpolation polynomial. Okay, interpolation model. That is your trial solution. Okay, and out of this trial solution, this is the multiplier of this unknown parameters. Now this multiplier is function of x, and this multiplier is taken as a weighting function in Galerkin method. So here, if you go to combine this finite element method and Galerkin method, then we have already weighting functions. We get the direct weighting functions as a shape functions. That means shape functions we can use as a weighting functions when we apply the Galerkin method for our finite element formulation. Okay, now if you have doubt, you can ask me. Here this is d5 bar minus. Yes, doubt आएगा कोणाचा? हाँ कौन है? Someone want to ask doubt? And this equation here we are taking the product of residual and weighting function, and this product is integrated over the domain and equated with the zero. That will give the unknown parameters, and when we get the unknown parameters, we will get the solution to the problem. Okay, now you have to remember the steps of the Galerkin method. Here I will clear it. You see here, it is weighted residual method. First step is approximate the solution same to that, then put that approximate solution in the governing differential equation and solve that governing differential equation by using this approximate solution. Then you calculate the residual. After that, you will select the weighting function as a multiplier of this parameter. Okay, that is a function of x. After that, you go to the integration of that product over the domain and equate with the zero. Okay, now you have to remember this weighting function is a multiplier of unknown parameters. Okay, that is wi is equal to fix. And in finite element method, we have shape functions as a multipliers. Okay, Galerkin method is generally used in a finite element formulation because in FEM shape functions are multipliers of unknown parameters. Okay, and shape functions are used as a weighting function. Therefore, that product becomes Nix into d phi by d phi minus f over dv equal to 0. Okay, this approximate solution satisfies the required criteria. One more thing I have missed that your approximate solution should satisfy the boundary conditions. Okay, should satisfy the boundary conditions. You have to remember these steps, these 4 steps. First, assume the trial solution. Put the trial solution in the governing differential equation. Next, by putting the trial solution in the governing differential equation, calculate the residual. Then next, select the weighting function. Next, take the product of weighting function and residual, or residual and weighting function, and integrate the product over the domain. Equate that integration with the 0. That will give the solution to the problem. And multiplier of the this unknown parameters is a weighting function. Okay, this is weighting function. Okay, now tomorrow I will prove it how by taking the examples, numericals on this. Not tomorrow, at the time of next lecture. Before that, here you have to. I will upload this part up to steps of Gallican method. Okay, you have to read these steps, and here you have to remember each and every step. You have to remember each and every step. Have you got it?